Hey, fifth grade, happy Friday. So, this is Miss Gibson coming to you with math for today. So, in your packet, you should be on Friday, March 27th, math. At with you in front of you, you should also have a pencil, eraser, scratch paper to help you work out anything that you need to do on scratch paper if you don't have space in the regular packet. So, again, you are going to work on this packet for Friday. And then after that, when we pause the video, then you're going to come back when you're done, and then we're going to go over some answers. So go ahead, pause the video, and get started. All right, welcome back. So the first thing that you guys had to do was fact power. So you can go ahead and look at this. Make sure that if you have anything incorrect, that you are starring or circling this so that we can conference on it with your teachers and we can clear up any misconceptions that you guys have. So as we're going through, make sure you're pausing the video so that you can check your work on things that we are not discussing in depth. Okay. So number one asks, the dimensions of a stamp are 5/6 inch and 7/8 inch. How can you find the area of the stamp? We already know that whenever we're doing area is length times width, so you should always be doing multiplication when it comes to this. You should never be switching anything, and you should clearly be multiplying the numerator times the numerator, denominator times the denominator. This is how I got the answer B. And did 5, 6 times 7 eighths equals 5 times 7 as a numerator, 6 times 8 as denominators, which leads me to 30, 35/48. Okay. Solve these problems by finding the difference. I did some for this in a couple of different ways, just so you guys can work on this. So we did a number line down here. You're finding the difference by subtracting over and over to get to the final answer. Number two, we subtracted on both sides of the problem, so the constant difference between each side to get to 4/11/12. And then down here for number 3 and 4, we just did the regular subtraction algorithm, and then we made sure that they had the same denominator in order for us to subtract. Go ahead and pause the video, check my work as these answer choices, well, with the answers, and then check how your strategies are working for you. Again, if you are not comfortable with a strategy, maybe we can conference on that as well. Write down what you're working on, which one you're struggling with, so then we can work on that. All right, let's move down. Okay. Eliel is finding the area of a room that is 5 and 2/5 feet by 6 and 1/8 feet. He determines that the area of the room is 33 and 3/40 square feet. Is his answer reasonable? Why or why not? So, whenever we're thinking about if an answer is reasonable, we need to base it off of an estimate, correct? So, if we were to estimate this, what would our estimation be? So, I want you guys to write that down. Exactly. Our estimate will be 30 because we can take the whole numbers since the fractions are close to the whole numbers right here, do 5 times 6, which gives us 30. So technically his answer does seem reasonable based off of what our estimate would be. Now we have to check if it was accurate. So I did an area model in order to prove this. So of course, when you're doing an area model, you need to make sure that you are hitting every single piece of the mixed number, okay? So this is where I did 5 times 6, and then down here, 2/5 times 6. So I made sure that 6 was multiplied by both pieces of that mixed number, just like we do for distributive property. 1/8 was multiplied by the 5, and also multiplied by the 2/5. Now, whenever I decide to add, can we add numbers with different denominators? No, they need to have the same exact denominator in order for us to add or subtract always, okay? So I had to convert these two pieces of my area model to make sure that they match my denominator in my final block right here. Now, of course, after you're doing the area model, you need to add all of these pieces together to get to the final answer. Check my work, check your work, circle this if this is confusing to you. Again, we can always conference on this. All right. What is the product of 3/8 times 1 and 1/6? Again, this is another example of making sure that you are multiplying pieces to all of the parts, okay? So you have one fraction multiplying by a mixed number. So I made sure that I multiplied the 3/8 times the 1 and the 3/8 times the 1/6, like distributive property, and then I added these two together. Of course, I always have to change my denominator if they are both unlike terms before I add. I made sure to do that and then got to my answer 21/48, which matches 1/2 because, oh, I'm sorry, not 1/2, my bad, which matches A 7/16 because if I divide 21 by 3 and 48 by 3, then I will get to A because I know that 3 is going to be a factor of 21 and 48. So if you wrote out all the factors for 21 and wrote all out all the factors for 48, you know that the common factors that show up is both 3. So I had to divide by a um, form of 1, which would be 3 over 3, in order to get 7/16. Okay, solve by converting to FGTOs and modeling. So of course, this is showing you two different ways. This is asking you two different ways, okay? So I first did the FGTO way. You know that when you're taking an FGTO, that you need to take it from that mixed number and make it a fraction greater than 1. So I made 1 and 2/3 5/3. I made 1 and 1/2 3/2. And then after that, I am multiplying them across. Do we need to change the denominator to make them like denominators when we're multiplying and dividing? No, because the number is going to change. You do not need to ever change the denominator when you are multiplying or dividing with fractions. So please do not ever get into the habit of doing this. It is a bad habit to have. You do not change the denominator when we are multiplying and dividing. Okay? So once I did that, I got 2 and 3/6. Once I converted it back, you should always convert it back to a mixed number. And then, of course, my final answer is 2.5. Now, when I did an area model, of course, I made sure to multiply each part of the mixed numbers to each other. Okay? Don't ever forget that step. Now, in this problem, once I have my pieces of my area model, I have to make sure we all have the common denominators because we have to add them up in the end. So you can go ahead and pause the video here and check your work. All right, scroll down. Solve with an area model. Again, this is just getting into the same habit that we've been working on, making sure that you're always hitting the exact parts of every piece of the mixed numbers. Sometimes a lot of us tend to just multiply the whole numbers by each other and then multiply the fractions. So this is why we are getting into this habit of constantly showing how to model this, just so you guys can work on this, all right? So my final answer is 6 and 6/15. Go ahead and pause the video here and check your work. All right, welcome back. Scroll down. So, what equation can be represented by the model below? Now, realize I have 1, 2, 3, 4, 5, 6. Okay, things represented as a fraction. In each of these bars, 3/4 are filled. So I know that this is 3/4 repeated 6 times, all right? So I want you to realize that we are not just counting the shaded parts as just a whole number. So that's why A is wrong. Realize these are bars, and this is supposed to be considered as a whole, like the whole thing as a whole. And then each bar is split into fourths, and then 3 of those fourths are shaded. So A is out. B, 1/4 times 6. This area right here is not shaded, so it does not depict what we are trying to go for when we are looking at these types of images. All right, so B is out. C, 4 times 6, it's the same exact thing. You cannot just count all the pieces and then say, oh, I have 4 pieces, I'm going to multiply this by 6, because that does not represent what these bars are doing. So it's a bar split into fourths, shaded 3 times. Okay, 3 of the boxes are shaded. So these all represent 3/4 and then repeated 6 times, which is why D is correct. Okay, go down to the next one. Jean needs 2.5 cups of flour to make sugar cookies and 3.5 cups of flour to make peanut butter cookies. What is the total number of cups of flour that Jean will need to make both kinds of cookies? Now, you have to choose the correct operation in order to solve this problem. Okay? So I want you to ask yourself, how do you know that this problem is not multiplication? Exactly. It is asking you the total number of cups. It is not asking you to find a fraction of a set or finding 2.5 cups of 3 and 1/4 cups. It's asking you to find the total number of cups, which means I need to add how many she's used, how many cups of flour that she will need to make these types of cookies. Okay? So, of course, when I'm adding, I did 2.5 plus 3 and 1/4. I had to convert 2.5 to 2 and 2/4 in order to add, of course, our fractions together, and then ended up with 5 and 3/4 cups of flour that she will need to make these cookies. So answer choice B is the correct one. All right, let's keep it going. Now, using a number line to solve the following problems, you should be solving by counting up. So I did not use this method when we were showing the other ways to solve by multiplying subtracting mixed numbers. So this is all going to be all on counting up only. So this strategy is very important as well. Okay, so I have 8 and 2/3 minus 2 and 1/10. So I'm going to go over one, and then you guys are going to check your work on the others. Of course, you need to be starring, correcting your work as you go, and making sure that you are understanding all of these concepts. Okay? So 8 and 2/3 minus 2 and 1/10. Now, before I do anything, of course, since I'm adding or subtracting, I need to make sure we have common denominators. So I converted both of them. When I am counting up, I am starting with my second number, okay, and putting it right here at the first part of my number line. Then I'm going to end with 8 and 2/3. Well, in this case, 8 and 20/30, because this is where I need to find that difference between these two. And in order for me to find that, I'm going to count up. So I'm going to start with 8 and 3/30. I'm going to add 6. Okay. The reason why I'm adding 6 is because I'm trying to get, again, to 8 and 20/30, which is right here. So I'm adding 6 wholes. I'm not there yet, right? So that means that right now I'm at 8 and 3/30, and I need to get to 8 and 20/30. So I'm going to keep adding fractions until I get here, okay? So after that, I'm going to add collectively how many times I just tried to jump up by counting up to 8 and 20/30. My total is 6 and 17/30. Okay. Now, this is the same strategy for the rest. I want you to pause the video here to check the first two, and then we're going to come back to look at the next two. All right, moving on to the next two. Again, make sure it's one up here, then one down here, just for clarification. Make sure you are always converting to common denominators. If they're already common, then you don't have to. And then check your work. I am going to go over one of them with you because this one is different. So this 7 2/5 minus 2 4/5. And I'm going to explain why. So realize I'm here 2 4/5, correct? I need to get to 7 2/5. Before, I was just adding to get to that whole number of my first number. I can't do that in this case. The reason why I can't do that because if I actually do +5, I'm gonna go over that 7 2/5. It's gonna end up being 5 4/5, right? So you need to make sure that you are adding the respective whole number, and then after that, adding in how much fraction pieces you need. Because if you go over, then that means that you didn't do what you need to do, which is counting up to the final number. So you need to make sure that you are adding the correct whole number and correct fractions in order to get to this final 7 2/5. So I added 4 instead of 5. That's a 6 4/5. I added 1/5, which got me to 7. Then I added 2/5, which got me to 7 2/5. So my final answer is 4 3/5. Again, pause the video, write down some notes. If you feel like you are confused on this strategy for counting up, star it so we can chat about it with, of course, with your teachers. All right, let's scroll down. We're almost done. So, Sebastian is solving 2.5 times 4 1/4. He gets 8 2/8. Is his answer reasonable? Why or why not? Now, I said his answer is reasonable because if you estimate that is 2 times 4, which equals 8, 8 is around 8 2/8, correct? So now let's check the work. Is it accurate? I did my area model for this, and of course, once I got the final answer, it's incorrect. Okay? I want you guys to try and figure out what he did wrong from his work compared to our work. So silently take a moment and jot down an idea of what he did wrong with his answer. So again, he got 8 2/8. What did he do? Exactly. He multiplied the whole numbers together and then he multiplied the denominators to get to 8 and then added the numerators. We don't do that. Okay, guys? Remember, if you ever feel confused about how you should be multiplying mixed numbers, always go to the area model because it'll make sure that you hit every single piece of what you need to hit. Okay, I know that I am multiplying the whole numbers, I am multiplying the fraction by the whole numbers, and then I'm adding them all up together in the end to get to my final answer. All right. So make sure you are never skipping a step when it comes to this part. You have to hit every single piece of that distributive property. All right. What fraction multiplication problem is shown in the model below? So 2 out of the 6 pieces are shaded. I want you guys to realize this. Okay. So if I were to solve all these, this is a great strategy for you to use whenever you have this. Go ahead and solve them. If you didn't do that, take a couple seconds to solve these. Multiply them, solve them, get the final answers. All right. So I know that A equals 1/4, B equals 1/6, C equals 2/6, and D equals 2/9. Now, I can automatically take out A because there are not 4 pieces here as my denominator. Take out D because there are not 9 pieces here as my denominator. Now, I'm going to be looking at my numerator because the numerator always represents that double shaded part that we used to do in class. So this should represent y 6 is equal to C, okay? B is not the correct answer because I don't have one piece shaded. I have 2 out of the 6 pieces shaded. All right, scroll down. Now, these are the last couple problems. So we are basically working on making sure when we are multiplying a whole number times a fraction, you are only multiplying that whole number to the numerator. Because technically, if we look at this in a different way, if I have 15 wholes, that means I have 15 ones repeated over and over and over and over and over again. So I have 1, 1, 1, 1, 1 15 times. So one whole, one whole, one whole 15 times, which is why I'm only multiplying that whole number by my numerator. Okay, so I'm doing 2 times 15 just as an example. I'm doing the same exact work down here for A and B. Realize these two are the same, so that's why they're down here. 2 times 15 over 3 equals 30 thirds equals 10. Make sure you're getting to this final answer. Don't leave it as a FGTO. B, 5 fifths times 12 equals 5 times 12 over 4 equals 60 fourths, which equals 15. All right. Again, as you were working and going through your answers, you should have been starring anything or any strategy that you were having a problem with. Make sure you were doing that and coming back to me so that all your teachers so that you can get clarification and have a conference on what you think that you were confused on. All right. So keep it up. See you guys on Monday. Hope you guys have a safe and cool weekend. Bye.